Welcome back. We are talking about wastewater treatment, under which we are discussing about the various treatment operations of a secondary treatment system. In this module or video, we will be discussing about some sample calculations so that the conversion factors will be much clearer. Let us take one particular case, how to determine the percentage of solids in the wastewater treatment. Because the concentration of the solids is usually expressed in milligram per liter, and how to convert this in terms of percentage. So determine the percentage of solids if the MLSS concentration is 4000 milligrams per liter. So to convert this into percentage, we should find out a suitable factor which will be expressed in terms of milligrams per liter. Usually the wastewater is mainly water. We consider it as a density of water. So density of water is equal to 1000 kg per meter cube. Converting 1000 kg per meter cube into milligram per liter, 1 kilogram is equal to 1000 grams and 1 gram is equal to 1000 milligrams. So totally it is 1000 into 10 to the power of 6 milligrams and divided by meter cube. So meter cube is equal to 1000 liters. So that also we have to write here. So now using this information, what we are getting is the density of water in the kilogram per meter cube is now converted as 10 to the power of 6 milligrams per liter. When you are taking a fraction of any solids concentration in milligram per liter, so we should compare that with this 10 to the power of 6 milligram per liter converted to fractions. The percentage of solids is equal to concentration of solids in milligram per liter in divided by 10 to the power of 6 and then multiply by 100, convert into percentage. So 4000 milligram per liter divided by 10 to the power of 6 into 100 is equal to 0.4 percentage. Similarly, determine the solids concentration if 1% solids are found in a sample. Sometimes the solids concentration are expressed in 1 percentage or 2 percentage, 0.1 percentage. So that should be converted back into milligram per liter. How you are going to do that? Percentage of solids is equal to 1%. It is equal to 1 by 100. And concentration of solids from the above equation is equal to percentage of solids and into 10 to the power of 6. So what you are having is concentration of solids is equal to 1 by 100 into 10 to the power of 6 coming out to be 10,000 milligrams per liter. So usually the written sludge concentration sometimes is expressed in terms of percentage. 10,000 milligram per liter is equal to 1%. 15,000 milligram per liter is 1.5%, like that. So now another calculation is how to determine the volume of aeration tank and also how to determine the HRT, hydraulic retention time. Determine the volume of an aeration tank for a sewage flow of 1000 meter cube per day with a HRT of 4 hours. So what we know, discharge is equal to volume divided by time. Here is nothing but HRT. So that volume is equal to discharge multiplied by HRT. The volume is equal to discharge 1000 meter cube per day into 4 hours. Here it is given in terms of day, it is in hours. So it should be converted into days, divided by 24. So that finally what you are getting, the consistency of units is now followed and the volume is comes out to be 166.67 meter cube. Determine the HRT in an aeration tank handling 1000 meter cube per day of sewage and having 250 meter cube of volume. Again, we go with the same logic. Discharge is equal to volume divided by HRT. So HRT is equal to V by Q. So HRT is equal to V is 250 meter cube divided by discharge is equal to 1000 meter cube per day. meter cube gone, what you are going to left is with days. So it is 0.25 days. But usually HRT is expressed in terms of hours. So to convert the days into hours, we have to multiply with 24 to get 6 hours. Determine BOD loading in a aeration tank. This is the next case we will consider now. So determine the BOD file loading in an aeration tank having a volume of 500 meter cube and inlet of BOD of 300 milligrams per liter. So how much BOD loading is there in the tank having a volume and BOD? So BOD file loading, how you are going to find out is volume multiplied by BOD 5 entering in the aeration tank. This is what we have to calculate in terms of milligrams per liter. So therefore, BOD file loading is equal to, this is 500 meter cube volume and BOD 5 entering is 300 milligrams per liter. Here volume is expressed in terms of meter cube, here it is expressed in terms of liters. So there should be a continuation of these units. So 1 meter cube is equal to 1000 liters. So you express that. So 1000 liters per meter cube. And finally, what you are going to get is 150 into 10 to the power of 6 milligrams. But milligrams is very small unit. So we convert into higher values. So 1 kilogram is equal to 1000 grams and 1 gram is equal to 1000 milligrams. Hence 1 kilogram is equal to 10 to the power of 6 milligrams. So you divide this 150 10 to the power of 6 milligrams by 10 to the power of 6 milligram per kilogram. What you are going to get is 150 kilograms. The other problem is determine the BOD file loading in aeration tank handling 1000 meter cube per day sewage and inlet BOD of 300 milligram per liter. In the previous problem, we considered volume and BOD, and here we are considering the discharge and BOD. With some discharge, the sewage is coming having some known value of BOD. How to calculate the BOD load from the inlet water. So BOD file loading in terms of kilograms per day is we going to apply similar formula. Discharge in terms of meter cube per day and BOD 5 entering in terms of milligrams per liter. So use that formula. BOD for file loading in kilograms per day is equal to discharge is given 1000 meter cube per day and BOD 5 entering is 300 milligrams per liter. Again here the change of units per volume. Here it is meter cube, here it is liter. So meter cube is higher. So 1000 liters per meter cube. So you put that here, what you are going to get 300 into 10 to the power of 6 milligrams per day. But already we have seen 1 kilogram is equal to 10 to the power of 6 milligrams. So remove this 10 to the power of 6 milligram and put it in terms of kilograms. So it's equal to 300 kgs per day. Determination of volumetric loading in a tank, aeration tank. Volumetric loading is nothing but how much BOD load entering per unit volume of the tank. So volumetric loading is equal to discharge into BOD entering divided by volume of the tank. So what is the problem given here? Aeration tank having a volume of 500 meter cube, inlet BOD of 300 milligram per liter and a flow rate of 1000 meter cube per day. So previously we have just now calculated when flow rate is given and BOD loading is given, we can calculate how much is the BOD loading in the tank. So that is nothing but the discharge into BOD entering is the loading coming on to the tank per unit volume. So 1000 meter cube per day into 300 milligrams per liter. Here again contrast with volume, meter cube and liter. So convert the meter cube to liters so that multiply 1000 liters per meter cube here and divided by 500 meter cube is the volume. So subsequently what you are going to get is numerator is 300 kg per day, denominator is 500 meter cube, and you are going to get 0.6 kg BOD per meter cube. So here we are converting milligrams to kilogram. When you are converting kilograms to milligram, please remember we are using this conversion. 1 kilogram is equal to 10 to the power of 6 milligrams. Determine the volumetric loading in aeration tank having a volume of 500 meter cube, inlet BOD of 300 milligram per liter, and flow rate as 10 mld. Previously, we are talking in terms of 1000 meter cube per day. Now we are talking in terms of mld. So how the conversion changes? The formula is not changing here. How much BOD is there attached with the discharge per unit volume of the tank? The formula is same. So discharge is equal to 10 mld. So therefore 10 mld means 10 into 10 to the power of 6 liters per day. So 1 million liters is equal to 10 to the power of 6 liters. So 10 into 10 to the power of 6 liters per day. So you are multiplying all these things here. 10 into 10 to the power of 6 liters per day is the discharge, multiplied by 300 milligram per liter. So now what you are seeing here both sides we are having liters and liters. Liter gets cancelled out here. Liter will get cancelled out. Ultimately, what you are going to get the numerator milligram per day into 10 to the power of 6 divided by 500 meter cube. What you are going to get 3000 kg per day divided by 500 meter cube. Why kg here suddenly? Again, this is 10 to the power of 6 milligrams. 10 to the power of 6 milligrams is equal to 1 kilogram. The conversion already we are taken care of. 3000 kg per day divided by 500 meter cube of tank volume is going to give you 6 kg BOD per meter cube. So these are two different forms of converting the values from discharge in terms of meter cube per day and MLD to calculate the volumetric loading. And then we'll see the F by M ratio, the put to mass ratio in aeration tank. Determine the F by M ratio in aeration tank having a volume of 500 meter cube, MLSS of 3000 milligram per liter, inlet BOD 300 milligram per liter, and flow rate is equal to 1000 meter cube per day. MLVSS by MLSS is equal to 0.8. Okay. So what is the F by M ratio? Food to mass ratio. Food means how much amount of organic matter entering into the aeration tank, divided by mass means how much of microorganisms they are available. So when you're expressing in terms of MLSS, now we consider in terms of MLSS. If we consider in terms of MLVSS, mixed liquid volatile suspended solids, we have to apply this conversion. So both the ways we can adopt, there's no wrong in it. So now Q into L naught by Vx. So Q is equal to 1000 meter cube per day, L naught is equal to 300 milligram per liter, V is equal to 500 meter cube, X is equal to 3000 milligram per liter. This is your MLSS. As per the given problem, this is your MLSS. Mixed liquor, suspended solids. So substituting this equation, F by M ratio is equal to 1000 meter cube per day into 300 milligram per liter divided by 500 meter cube into 3000 milligrams per liter. So here no conversion factor is required because the numerator we are having milligram per liter and milligram per liter gets cancelled out, and meter cube will get cancelled out. So conversion is not required here, unlike in the previous case. So calculate all these values, 1000 into 300 divided by 500 into 3000, which is equal to 0.2 in terms of MLSS. In terms of MLSS, this value. Suppose if you use MLVSS, mixed liquor volatile suspended solids, then this MLSS should be converted into MLVSS using this formula. So MLVSS is equal to what? MLVSS is equal to what? 0.8 times whatever is the concentration of MLSS. 0.8 into 3000, that is equal to 2400 milligram per liter. So if you put that value, what you are going to get is F by M ratio will be equal to 0.25, where you are substituting this value in place of X. When you are keeping MLSS in this formula, you are getting 0.2 and 0.25 when MLVSS are considered. Because why we have to consider these differences? Because MLSS consists of a number of solids, different types of solids. Organic solids, that is volatile solids, some inert material, and some dead cells. So many things are there. So MLVS represents the active biodecomposable or biodegradable material. They are present in the MLSS. That's why MLVSS is mainly considered as a important parameter instead of MLSS. Like MLSS is having a total mixture, which is useful and also not useful. MLVSS is giving a portion of the useful biodegradable organic matter. That is the port. That's why MLVSS is sometimes used in the equations. Determine the MLSS value if volume of aeration tank is 500 meter cube, inlet BOD is equal to 300 milligram per liter, flow rate is equal to 1000 meter cube per day, and F by M ratio of 0.4 is adopted. The previous problem, we have calculated the F by M ratio. Now F by M is given, we have to calculate the X value here. Formula will not change. The same formula we are going to use, and you substitute the values here. And finally, you find out X is equal to here 1500 milligram per liter. 1500 milligram per liter. This is we are calculated in terms of MLSS. If you want to convert this into MLVSS, which is equivalent to 0.8 times of this, so it is equal to 1200 milligram per liter. Okay, thank you.